1 minute only. So we studied these formulas. Gamma function, gamma n equal to integration from 0 to infinity e raised to minus x, x raised to n minus 1 dx. Gamma n divided by k raised to n. This was the value of this integral 0 to infinity e raised to minus kx, x raised to, I am audible? X raised to n minus 1 dx.
Yes, sir.
Yes, sir.
Good. Gamma 0 equal to infinity, gamma 1 equal to 1, and gamma half equal to root of pi. Then we obtained the value of gamma function. Gamma n was equal to n minus 1 factorial whenever n is not a fraction. So n is positive integer. Okay, and here n is positive fraction. Okay, as well as we studied this formula 1 minus p gamma 1 minus p equal to pi divided by sine of p pi, where p lies between 0 to 1. This formula is you have to remember to solve the examples on gamma function, and remember that inside the integral what we want, these terms are required, exponential term and x raised to something, and limit should be 0 to infinity. Okay, so right, type number 3. Let 1 evaluate. Type number 3, let evaluate. Integration from 0 to 1. X log x raised to 4 dx. So I equal to so see inside the integral we don't have exponential terms, so e raised to minus x is required, as well as limits at this moment they are 0 to 1. So we have to use a suitable substitution so that we'll get exponential term e raised to minus t, for example, inside the integral, as well as limit should be converted into 0 to infinity. Yes, what should be done? Anyone? What should be substitution? Substitute? Anyone? What should be substitution so that both the properties will be satisfied? T equal to? Yes, T equal to what? Fast. T equal to what? T equal to log x, say. We'll see what will happen. Okay. We'll just see what the limits will be. Limits of x are known to us. Right? We'll try to find the limits of t. Limits of x are 0 and 1. We want to find limits of t. Log of 0. What is log of 0? Minus infinity. Log of 1, 0. Yes, we are getting the limits, but we are getting minus infinity to 0, but we are interested in 0 to infinity. So this will not work. This will not work.
सर माइनस log x लिया तो
वेरी गुड, करते हैं t इक्वल टू माइनस log x लेते हैं, है ना? तो अभी लिमिट्स देखते क्या आएंगे. See what the limits are. X and t. Log of 0 minus infinity, but already minus sign is there. Minus minus plus infinity. Log of 1 0, whether it is 0 or minus 0 doesn't matter. Okay, so we are getting the limits. Let me continue. Let me change the page and we'll see what will happen when t equal to minus log x is there. T equal to minus log x. So log x equal to minus t. So what the x is? E raised to minus t. Okay. Therefore, what is the dx? Minus of e raised to minus t dt. Okay. So 1, 2, limits are known to us. Limits are infinity to 0. Therefore, the integral will become infinity to 0. X is e raised to minus t raised to 4. Log x is minus t raised to 4. Dx is minus of e raised to minus t dt. Simplify. Minus sign outside. E raised to minus 4t. T raised to plus 4. This minus sign is written outside. Huh? E raised to minus t dt. Consider negative sign to change the order of integration. Hope everyone know that. Whenever we change the order of integration, minus sign is to be attached. Okay, now let me use this formula. Gamma n divided by k raised to n. Right? Before some time we written the formula. So what is k here? E raised to kt. E raised to minus 5t. K equal to 5. Power of t is 4 here, and in formula n minus 1. Okay, so the value of integral is gamma n divided by k raised to n. Gamma 5 divided by 5 raised to 5. 4 factorial divided by 5 raised to 5. This is the answer. Hope everyone is getting this way of solving the example. Understood? Can I change the page? Hope everyone is here. Only 68. What about others? Okay, let me change the page. I'm audible?
Yes, sir.
Yes, sir.
Let me change the page. Right now, next example, second example. Evaluate. Right, integration from 0 to 1. X divided by root of log of 1 upon x. Yes, what should be substitution? Anyone? What should be the substitution? कोई बता सकता है क्या substitution आना चाहिए? T equal to log 1 upon x, that will work. T equal to log of 1 upon x.
टी स्क्वेअर घेतलं तर काय होईल सर?
T square. Don't afraid about the root, na? T raised to n minus 1. Sorry, x raised to n minus 1 is there, na? So n may be fraction, n may be whole number also. Don't have to take t square.
Okay.
Acha, whether we have to take minus t or plus t. Acha, we'll decide that. Okay. So this is equal to log 1 minus log x. Log 1 is 0. So t equal to minus of log x. Isn't it? Therefore, log x equal to minus t and x equal to e raised to minus t. Clear? So what will be dx? Minus of e raised to minus t. So we are getting e raised to minus t. Okay. Now we have to check the limits. Limits are also very important. Limits. So t equal to log of 1 upon x. And limits of x are known to us. 0 and 1. What about t x equal to 0? So log of 1 upon 0. That is equal to log of infinity. And what is log of infinity? Infinity. Okay. Then log of 1 upon 1, x equal to 1. 1 upon 1 is log 1. And what is log 1? 0. So no any problem. Okay. We are getting all the required limits as well as required form of the gamma function. Okay. So 0 to 1, that becomes infinity to 0.
सर्व लिमिट्स दिख नहीं रहे सर क्लियरली.
Okay, let it here. X equal to 0 means log of t equal to log of 1 upon 0. Log of infinity. And what is log of infinity? Infinity. X equal to 1 means t equal to log of 1 upon x. So 1 upon 1. So log of 1. And what is log of 1? 0. Okay, so infinity to 0. Then x e raised to minus t dx minus of e raised to minus t dt divided by root of log of 1 upon x, root of t. Okay, so minus sign outside. Change the order of integration. This is the formula. Gamma n divided by k raised to n or n plus 1. I forget that. K raised to n, I think. Who remember the formula? किसी को याद है क्या formula? K raised to n prove किया था, k raised to n plus 1 prove किया.
K raised to n.
N only ना? K raised to n ही है.
Sir, n.
Okay. So k equal to e raised to minus kt, e raised to minus 2t. So k equal to 2 and n minus 1 equal to minus half. So n equal to plus half with these two values. So the value of integral is gamma n divided by k raised to n. Gamma half divided by k raised to half. Root pi. 2 raised to half means root 2. This is the answer. Root pi by 2 is the answer. Hope you might have understood it. Next, Radon. Can I change the page? Page change कर लूँ क्या मैं भी?
Yes, sir.
Okay. So type number 4. Actually, they are not of different type, but for understanding, we have made the 4 different types. Okay, what is the exponential function? A function whose base is constant and power contained variable is known as exponential function. What is the exponential function? Base is constant, but power is not constant. Okay. For example, e raised to 2x. So base is e, and e is constant. We know the value of e, 2.717, right now? Now say I say 5 raised to x. Is it an exponential function? Yes. A raised to x. Is it an exponential function? Yes. A raised to minus x. Yes. These are the examples of exponential function. Okay. Hope you are getting it. Okay. So next example, evaluate. Zero to infinity dx divided by 3 raised to 4x square. Yes. Can anyone tell me what should be the substitution? What do we want? What our aim is? Limit 0 to infinity. What is required for the gamma function? Gamma function is like this, na? Integration from 0 to infinity e raised to minus t raised to n minus 1 dt. So these are the fixed terms. Limit is fixed. It should be 0 to infinity. Yes, we have 0 to infinity. A exponential term should be e raised to minus t. And then t raised to some power that can be adjusted. Okay. So what should be substitution? Substitute. Yes, anyone? Can anyone tell me what will be the substitution? 3 raised to 4x square. This is the exponential term. That should be equal to e raised to what? Plus t or minus t?
Plus t.
Plus t, since 1 upon 3 raised to 4x square, it is in denominator, na? Therefore, take log on both sides. Take log on both sides. Log of e. Log of e equal to 1. Okay. Find x from here.
सर
आपण
3 to the power 4x square ला e to the power t पुट केलं ना
हो हो
म्हणजे t equals to 4x square येईल
नाही ना base should be same then it is so na base is different na on one side base is 3 on other side base is e okay
तर मग आपण असं जर पुट केलं सपोज 4x square equals to e to the power t
e to the power 4x square
T,
equal to
sir.
no how it will work then it will become 3 raised to e raised to t na that we don't want no we want e raised to minus t na okay derivative
समजत नाहीये सर थोडा प्रॉब्लेम होतोय
सांगा ना तुम्ही सांगा काय सबस्टिट्यूशन सांगा substitution you tell me the substitution I'll tell you why it is wrong e raised to t equal to
4x square
4x square okay then 1 upon 3 raised to 4x square right now that will become 1 upon 3 raised to e raised to t getting na
yes sir
that we don't want na we want e raised to something na we don't want 3 raised to something e raised to minus t required na therefore this will not work clear or not
okay sir
see or in other simple words limits are same that we required same as that they are in the gamma function clear okay now we want this exponential term so go to the example it also contain exponential term this is the exponential term so exponential term is to be replaced by exponential term only therefore 3 raised to 4x square equal to e raised to t clear Let me continue. Derivative of 1 upon root t. So 2 log root of log 3 as it is. Derivative is 1 upon 2 root t dt. Okay, so now limits will change. See how the limits are. So I'm writing t from here. From here I'm writing t. T equal to 4 log 3 into x square. Okay, so limits of x are known to us, 0 and infinity. Find limits of t. Substitute x equal to 0. 0 into 4 log 3, 0. Substitute x equal to infinity. Infinity into 4 log 3, infinity.
Infinity.
Okay. Therefore, the integral will become, I'll write it on next page. Written everything. Can I change the page?
Sir, 1 minute.
Right. Okay. So it is like this. We have the integral like this. 0 to infinity. No change in the limits. Dx equal to 1 upon 4 root of log 3 root of t dt. This is dx. And this is e raised to t. Simplify this. Gamma half is root pi. Hope you are getting the same answer. Understood?
Yes, sir.
Okay, let me go to the next part. Change the page. Change page. Right. Beta function. Okay. So we are studying what we are studying here, improper integral. Now what is improper integral? Limits are infinite. Okay, known as first kind of improper integral. Okay, second, function become infinite at limits. at limits. This is second kind of improper integral. And third, both above. Okay. Limits are infinity as well as the function the integral become infinite. Okay, so that is third kind of improper integral. If for example, gamma n 0 to infinity e raised to minus x raised to n minus 1 dx. So if we substitute x equal to 0, e raised to 0 is 1 and x equal to 0. So the integrand will become 0. If you substitute infinity, e raised to minus infinity equal to 0. So it does not become infinite at any limit. Okay, so it is of first kind. Improper integral of first kind. Okay, now consider this integral. Zero to one, sorry. 0 to 1. So if substitute x equal to 0, we have 0. At x equal to 0, the integral equal to 0. At x equal to 1, the integral become 0. And again, it depends upon this n minus 1. Okay, so it is improper integral of second kind. Okay, so write down beta function. Now formal definition of beta function. Now write with me beta function. Right. Beta function of m comma n is denoted by, this is the notation, b and in bracket m comma n, where what is required? M and n should be greater than 0. M comma n, it is not multiplication. M comma n is greater than 0. And it is given by x raised to n minus 1, 1 minus x raised to n minus 1 dx. Why we are studying beta function? That will help us to solve specific type of higher order integrals. Okay, we'll understand. Right on next page, can I change the page? I'm audible. आवाज येतोय माझा?
Yes, sir.
Yes, sir.
Okay. Okay. Chalo. Let me change the page.
Yes, sir.
Right. Properties of beta function. What is commutative property? Commutative property means a plus b is equal to b plus a. A into b equal to b into a. So addition is commutative, multiplication is commutative. What about subtraction? Is a minus b equal to b minus a? No. What about division? Is a divided by b equal to b divided by a? No. Okay. So only addition and multiplication are commutative, whereas subtraction and division are not commutative. What about the beta function? Beta function is commutative. That is, beta mn is always equal to beta nm. We'll prove this. Beta mn, we can interchange m and n. Yes, Radha. Since In other words, I can interchange the power of x and 1 minus x. That we have to prove. M minus 1, n minus 1. Yes, what should be substitution? Anyone? हाँ, substitution क्या होना चाहिए? कोई बता सकता है? t equal to 1 minus, ये लेके देखते हैं क्या आता है. ठीक है? What is dx? What about limits? हाँ.
सर आपने
So that is
integration कर
m
दिया।
plus 1 or m1?
ये वाला ना, ये माइनस है m minus 1, x raised
Yes,
to
sir.
m minus 1, 1 minus x raised to n minus 1. माइनस है दोनों. चलो आगे बढ़ते हैं. लिमिट्स हम लिख रहे हैं. वी आर राइटिंग लिमिट्स. Limits of x are known to us 0 and 1. We want to find limits of t. Substitute x equal to 0, 1 minus 0, 1, 1 minus 1, 0. So the integral will become integration 0 to 1. That will become 1 to 0. Here it is. X. What is the value of x? Here it is. 1 minus t. Raised to m minus 1. 1 minus x, that is t. Dx minus d. Take minus sign outside. Consider this minus sign to change the order of integration. That's it. First we have written n. Why? Since it is the power of t. Second we have written m. Why? It is the power of 1 minus t. 1 is added, no doubt. First read it.
सर प्रूफ नहीं लिखा तो चलेगा क्या?
बेटा झोप आहे लागल्या जीवनात. Okay, this is the first property. Write down. Second property. Beta function as compared to gamma function somewhat difficult, huh? So try to understand the properties of a beta function. First property we studied. We'll go to the next property. Write down. Now we have tried beta function in terms of sine theta and cos theta. Okay, so three different forms of the beta function. Okay, cite on next page. Right. Alternate form of. Beta function. Okay, so we'll start with the beta function directly. X equal to sine square theta. Yes, tell me what will be 1 minus x? 1 minus sine square theta. cos square theta. So the integral will become x replaced by sin theta and 1 minus x replaced by cos theta, like this. Find dx. Okay, now see how the limits will change. X equal to 0. Theta equal to 0. X equal to 1. So sin square theta equal to 1.
Pi by 2.
Pi by 2.
Absolutely. Okay, now substitute all the values. See, we know x, we know 1 minus x, we know dx, we know limits. These 4 values are to be substituted in given integral. So I, limits become 0 to pi by 2. X, that is sin square theta. 1 minus x cos square theta. Dx. Simplified.
Yeah, right. Sin 2 theta, d theta.
To outside. Correct. M. Hope everyone is reading this. Beta mn equal to 2 times. क्या विशेष है? Okay, return up to this step.
Yes, sir.
Okay. Now, let below this return 2m minus 1 equal to p and 2n minus 1 equal to q. So what the m is? N, sorry. P plus 1 by 2 and q is n is q plus 1 divided by 2. Therefore, let me write the above result in terms of this p and q. Okay, so we have this result: beta mn equal to 2 times 0 to pi by 2 2m minus 1 theta beta mn equal to 2 times integration from 0 to pi by 2 sin raised to 2m minus 1 theta cos raised to 2n minus 1 theta. Now write in terms of p. So let me take this 2 to other side. M. This is a new formula that we have developed. So one more in reduction formulas, we developed few formulas of this type. Integration program 0 to pi by 2, 0 to pi, 0 to 2 pi. Okay, and then integrand is sine raised to n theta, cos raised to n theta, d theta. Okay, the same way we have developed this formula, but here there is no restriction on p and q. There is no restriction that p should be even, odd, then integer, prime number. It doesn't matter. Formula is valid for all the values of p and q. Okay, now ready. Next, third. Alternate form of beta function. Zero to one x raised to n minus one minus x raised to n minus one dx. That is equal to integration from 0 to infinity. X raised to m minus 1 1 plus x raised to m plus n dx. We want to prove this. Yes, take 1 minute and see what will be the substitution. Try to decide the substitution for x or 1 minus x, so that we'll get limit at 0 to infinity and we should get the integral terms. First, take 1 minute and try. Anyone? Anyone getting the substitution? Am audible? कोई substitution बता सकता है? Yes. Try to go at least. Rohan, Darshan.
Sir, 1 minus
Nihil.
x raised to n minus 1.
1 minus
X raised to n minus 1 is equals to e raised to t something, kind of like that.
No. See, exponential term is not required here, na? We have x raised to m minus 1 and 1 minus x raised to n minus 1. We want to convert that in this form. X raised to m minus 1, 1 plus x raised to m plus n. So we'll start like this. Say I consider t equal to 1 upon 1 minus x. Tell me what will happen. We'll check the limits. T equal to 1 upon 1 minus x. X equal to 0. Substitute x equal to 0, 1. X equal to 1. 1 upon 0, infinity. So we are getting 1 to infinity, but we don't want 1 to infinity. We want 0 to infinity. Na? So how we can get this 0? Yes. ये 0 लाना है हमें, कैसे ला सकते हैं? कोई बता सकता है? जीरो कैसे ला सकते हैं?
So C
अरे
is
आपने
equal
पढ़ा हुआ
to
नहीं?
x upon 1 minus x.
x अपॉन
1 minus x.
ओके, चलो चेक करते हैं. x upon 1 minus x. Okay, so x equal to 0. 0 divided by 1, absolutely we'll get 0 here. x equal to 1. चलो इससे ट्राई करते हैं. Then tell me what will be. Okay, if I simplify this, if I cross multiply it like this, this is the x. Okay, good. Understood na? We have t as a function of x. Now we have written x as a function of t. So what is dx now? Division rule. 1 plus t as it is derivative of the numerator. Numerator as it is derivative of the denominator. Denominator square. Okay, you don't have to consider this. We can consider that also, correct. Also, so dx is known to us, then 1x is known to us, 1 minus x is known to us, yes. Okay, 1 minus x is remaining. Yes, limits t equal to substitute x equal to 0. So 0 divided by 1, 0. And then 1 divided by 0, infinity. Okay, so let me use all these values in the this integral and we'll see what will happen. Return all the values. X is t divided by 1t. Dx is 1 upon 1 plus t square. 1 minus x is 1 upon 1 plus t. Okay, therefore,
Yes, sir.
limits will become 0 to infinity. Let me change the page. X is, check what the x is. T divided by 1 plus t. See what the 1 minus x is. 1 upon 1 plus t. And what the dx is? 1 plus t raised to 2. Simplify this. What about limits? Is it 0 to infinity or infinity to 0?
0 to infinity. Na?
0 to infinity. Yes, sir.
Zero to infinity. Simplify this. T raised to m minus 1 divided by 1 plus t raised to m minus 1. 1 plus t raised to n minus 1 1 plus t square d. Simplify. Plus 1, minus 1 is minus 2, minus 2 plus 2 will cancel. And this is what we have to prove. This is the third form in which we can write the beta function. Okay, next few more formulas, but without proof, right now. Fifth, sixth, I forget that. Beta mn equal to gamma m gamma n divided by gamma m plus n. Okay, last. Right, duplication formula. Right, gamma m gamma m plus half gamma 2m. That's all. This is what you have to remember about the beta function. Tomorrow we'll solve examples. We'll go through the examples of beta function tomorrow, and after that, tomorrow we have 2 lectures. Huh? So in the second lecture, we'll start with the DYS rule, differentiation under integral sign. Let me take sign till that time. A division, rule number 1.
Present, sir.
2.
Present, sir.
3.
Present, sir.
4.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7.
Present, sir.
8. Absent. 9.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12.
Present, sir.
13. Fast. 13. Absent. 14. 14.
13, present.
13 present. 14 absent. 15.
Present, sir.
16.
Present, sir.
18.
17 present.
Present, sir.
75.
Okay. 19. Absent. 20. Absent. 21.
Present, sir.
22.
Yes, sir.
23.
Present, sir.
24.
Present, sir.
25.
Present, sir.
26. Absent. 27. 28.